So the other day we converted degrees to radians, and today we're going to convert radians to degrees. We're going to use the same fact, and we're going to use the same strategy of stoichiometry, but the fact that we're going to use is the fact that 180 degrees is equal to pi. We proved in class the other day that 360 degrees is equal to 2 pi, and it might be a little bit more difficult to just double the degrees and double the radians, especially when we're dealing with today some fractions. So we're just going to go ahead and do some stoichiometry, and we are still going to use the fact that 180 degrees is equal to pi. I'm just going to go ahead and use it in a fraction form so that we can kind of like cancel out the units that we want. So we're already in radians with the pi here, so I'm going to introduce a fraction to cancel out the radians. And since pi is equivalent to 180, I can just create this giant version of 1 right here. It's kind of like multiplying by 12 inches over 1 foot if I wanted to cancel out some units, but not for today, not for this problem. So I'm going to introduce degrees into the problem, and I'm going to cancel out the radians, so we can see that pi cancels out. So all I need to do right now is just 2 times 180, and then divide it by 3. So that's 360 up top, divided by 3 is equal to 120 degrees. So that is equivalent to 2/3 pi from radians. When we have 3/4 pi, we can go ahead and use the same idea. Even if the pi is not on the numerator, if it's listed to the side, we could still do that. It's still like it's in the numerator. It's kind of like pi over 1. So we're going to go ahead and cancel out the pi radians on the bottom, equivalent with 180 degrees on the top. Pi's are going to cancel. In this case, I'm probably going to do since I don't have a calculator, I'm going to do the 180 divided by the 4. And then I'm going to multiply it by the 3. And so 180 cut in half and then cut in half again, so that's 90, and then that's 45. And then if I have 3 chunks of 45, that will give me 3 chunks of 40 and 3 chunks of 5. So I end up with 135 degrees. Again, you can just as easily use a calculator to type in that part right there if you need to. Now we have 5/6 pi, so I'm just going to use the same strategy. And again, it doesn't matter how the fraction's written or where the pi is. I'm going to cancel out the pi radians, introduce degrees into the problem. The pi's cancel out. Now I have 5 times 180 divided by 6. I think 180 divided by 6 would be the easier part. That gives me 30 degrees. So now I have 5 times 30, and that gives me 150 degrees. And the last one, we have 4 pi. This one will be the easiest of them. I'm going to go ahead and cancel out the pi on the bottom, introduce degrees on the top. And I can use this fraction a different way if I needed to, but the reason I'm writing it the way I am today is so that the radians can cancel out, the pi's can cancel out, and then I'm just left with degrees in this problem. So if I want to do 4 times anything in my head, I'm just going to double it and then double it again. So 180 degrees doubled will give me to 360, and 360 doubled will give me to 720 degrees. So there's your little unit on how to convert radians to degrees.